65 million years ago, an object from space hurtled toward planet Earth at 150,000 miles per hour. On impact, it triggered a disaster unlike any ever conceived by man. Could this gigantic collision have ended the reign of the largest creatures ever to walk the land? For the dinosaurs, it was a day just like any other. Huge plant-eating giants browsed in the forests hunting for food, while vicious predators stalked their prey. Little did they know that this day would be the beginning of the end. The countdown had already begun that would lead to their annihilation. For centuries, what killed the dinosaurs has mystified paleontologists. Was it a natural disaster? An earthquake, perhaps? A flood? Or a volcanic eruption? Whatever it was, it had to be so catastrophic that it affected the whole planet. 65 million years later, all that's left of the dinosaurs are footprints and their petrified remains. Near the ghost town of Ludlow in southeastern Colorado, fossil footprint expert Martin Lockley has made an amazing discovery that helps document the dinosaurs' doom. He has found a relic from the last generation of dinosaurs to have walked the planet.
What we have here is a footprint, not the world's most beautiful footprint perhaps, but nevertheless a very important one. You can see, if you look closely, the outline of 3 toes. One here, the middle toe here, and then the other one would have been broken off here, and the heel goes around to the back. Now this is a fairly typical shape for a duck-billed dinosaur or a hadrosaur. If we measure this, it's about 24 inches, a couple of feet long, and the hip height of one of these dinosaurs is about 4 times the length of the footprints. We're looking at a hip height that's going to be about 8 feet.
This gentle plant eater couldn't have known it would leave its mark as one of the last dinosaurs on Earth.
This layer of rock here is the same layer that we found the hadrosaur footprint in over there. This whole sequence of rock here is extremely important and critical to the study of dinosaurs. This is a geological marker layer. It represents the end of the age of dinosaurs. So that footprint layer is only 14 inches below this. That probably only represents decades or at most centuries, not tens or hundreds of thousands or millions of years.
Geologists called this layer of rock the KT boundary, the moment between the Cretaceous period and the Tertiary 65 million years ago, when all the evidence of dinosaurs vanished. A major timeline in Earth history, the KT boundary can be seen sandwiched between layers of rock virtually around the world.
Everywhere we find the KT boundary, it's the same story. Below the boundary, lots of evidence of dinosaurs, tracks, bones, etc. But above, they appear to be gone, disappeared without a trace.
What could have killed all of these mighty beasts? To find out, scientists on the extinction trail are probing the KT boundary, though sometimes it's not that easy to get to.
We're obviously stuck here and we can't get down here to the arroyo. So basically what we would like to do is to borrow his horse and go through this slop and actually move some of our equipment.
For geologist Dave Kring, the rocky outcrop of Mimbral in northeastern Mexico is worth the hardship. Here, where the KT boundary is clearly distinct, samples have produced the first vital clue to the death of the dinosaurs.
The rocks that I am standing on were deposited when dinosaurs existed. Right at this level in this rock, the dinosaurs disappeared, and above it is an incredibly fascinating sequence of rocks. It's very thick, much thicker than the KT boundary sediments found anywhere else in the world. And way at the top of this sequence, we've taken samples into the laboratory and we found a very special element called iridium.
Iridium is special because it's rare. When scientists analyzed rock samples taken from the KT boundary in Europe, they were astonished to find 1,000 times more iridium than usual. The same massive amount was also found in rock samples taken from other sites around the world. If iridium is so rare, then where did it come from? Following a hunch, Dave Kring checked out some unusual rocks in the Tucson Planetarium in Arizona.
Iridium is a very rare to almost non-existent element in rocks in the surface of the Earth. However, we found huge abundances of this element in rocks deposited right at the time when dinosaurs disappeared. The fascinating thing about the element iridium is it is constantly being rained down on us by cosmic debris.
These are no ordinary rocks. They are lumps of minerals, iron, and other elements that fall to Earth from outer space. Only objects from space contain large amounts of iridium. Something must have bombarded the Earth, then disintegrated, sending a cloud of iridium-laden dust around the world. But cosmic dust didn't kill the dinosaurs. So, what did? The moon clearly shows the visible dents and scars of impacts from outer space. And, like the moon, the Earth has also been hit. Here, most craters are eroded away by millions of years of wind and rain, but some can still be seen quite clearly. The most impressive is Meteor Crater, near the town of Winslow, Arizona. To cosmologist Jay Malaj, the crater clearly shows what happens when big things, traveling very fast from outer space, hit the ground very hard.
This crater is 50,000 years old. Although it's a mile wide and 600 feet deep, it was created by a meteorite only about 150 feet across. An iron meteorite that struck the rocks on the surface here, traveling at about 150,000 miles per hour. It penetrated the rocks in only a wink of an eye, a tenth of a second, and deposited its energy, which blew this crater out in a matter of 10 seconds.
If this impact was so severe, then what kind of destruction could a much larger meteor do? There are giants circling the Earth even now. In 1995, Comet Hale-Bopp was seen for the first time. It's twice as long as Manhattan Island and more than 20 miles wide. Passing the Earth every 4,000 years, it's just one of hundreds of large comets and meteors that threaten our planet. If evidence of huge amounts of iridium proves that a meteor hit Earth 65 million years ago, how big was it? The amount of energy needed to create the devastation that would kill all the dinosaurs had to be gigantic. The problem has always been proof. If something really huge crashed into the Earth, then where was the crater? The first clue came unexpectedly in the Gulf of Mexico. While geologists like Luis Marin were surveying the Yucatan looking for oil deposits, an unusual round structure buried deep below the Earth's surface appeared on their maps.
They use different techniques. For example, they use a magnetometer, which is a cylindrical shaped instrument that is flown out of airplanes, and it allows one to cover large areas. They also drilled, both on land and at sea. In other words, they go down and bring back cores and examine them for the presence of oil and gas. They didn't find any oil. However, what they did find was this very strange looking circular anomaly in Yucatan.
This strange bowl-shaped structure was 150 miles across. When mapped, it revealed disturbances in the Earth's magnetic field, usually associated with ancient volcanic activity. But these rings are too uniform and too large to have been caused by a volcano. Luis Marin believes the rings are a smoking gun. The main square of the town of Chicxulub on the coast of the Yucatan Peninsula is situated right in the middle.
And so here we are, right dead center in the middle of this circular structure, which is 75 miles in that direction and 75 miles in that direction. It would take you 3 hours to drive from one side clear to the other side. Now, what is this structure? We know it's not a volcano because we have not found any volcanic rocks from the last 200 million years. The magnetic field that has been recorded in the rocks from this area is very large, especially compared to other volcanoes, and the size itself, it is too large to be a volcano. That can only mean one thing. A gigantic meteorite coming from outer space and hitting here, ground zero at Chicxulub, killing off all the dinosaurs.
Over the past 65 million years, this huge crater has been filled with thousands of feet of sediment. The presence of iridium and the discovery of the crater is proof positive a cosmic missile hit the Earth at about the same time the dinosaurs disappeared. But how could a single meteor careering toward the Yucatan kill the most successful creatures that ever lived? The last day of the dinosaurs, T-10 and counting. An object capable of awesome destruction hurtles towards Earth. At speeds of 150,000 miles an hour, it plunges into the atmosphere. Moments before the collision, the dinosaurs would have seen the meteor's shimmering head and fiery tail. Traveling at such an incredible speed, the air in front of this gigantic meteor was unable to escape, and with a brilliant light came a deafening blast.
Imagine this 8-ball is 150 feet in diameter, the size of the meteor that made Meteor Crater in Arizona. If it struck the Earth at 150,000 miles an hour, it would have made a hole a mile wide and 600 feet deep. That's big enough to store 500,000 tractor trailers inside.
The devastation is so complete that for a radius of over 50 miles, everything was obliterated.
Now, imagine this bowling ball is 12 miles in diameter, the same size as the meteor that crashed into the Yucatan Peninsula. Traveling at 150,000 miles an hour, and that's fast enough to take us from here in Arizona to New York in 2 minutes. Imagine the devastation that this would have caused.
A meteor this big would have stood higher than Mount Everest.
The impact would have been hundreds of times bigger than this crater. The energy released, 100 million megatons, would be equivalent to 100 million hydrogen bombs, all going off at exactly the same time and same place.
At ground zero, the dinosaurs and all other living things are instantly annihilated. Within seconds, shock waves unleash a fireball of vaporized rock and molten debris into the atmosphere. Two minutes after the impact, a mushroom cloud carrying particles of burning debris spreads over the land.
When these particles begin to rain into the Earth's atmosphere, the sky turns red. They create a radiant heat equal to that of a pizza oven. This goes on for hours. Now imagine the dinosaurs. Their hides would begin to smoke, burn. They would be literally roasted in their tracks, dying in agony as the heat sears the hides off of them.
The impact sparks a chain reaction beyond our worst nightmares. In rock samples he recovered from the KT boundary in northern Mexico, Dave Kring has found evidence of the burning debris.
These round objects are called tektites. These are once molten glassy beads of material that were thrown out by the Chicxulub impact crater. This impact event was so large that it threw this material clear across North America. And we now find it in a variety of KT boundary rocks like this sample from Arroyo El Membrao.
Green in color, this molten rock turned to glass as it fell to the ground. Under closer inspection, the teardrop shape of these deadly tektites can be clearly seen. But the dinosaurs weren't the only targets of these fiery glass balls. 10 minutes after impact, molten rain hits the ground, causing vegetation to spontaneously burst into flames. 1 hour after impact, tidal waves 400 feet high radiate from ground zero, crisscrossing the world's oceans. A wall of water as tall as a skyscraper hits the coast, submerging all of Mexico and most of the United States. Membral in northeast Mexico is hundreds of miles from ground zero, yet it still shows clear signs of the tidal wave.
65 million years ago, when the dinosaurs disappeared, this entire area was covered with a sea. When the Chicxulub impact event occurred 400 miles to the east, it threw out tektites, which then rained through the atmosphere and splashed down into the sea, forming this immense deposit of tektites beside me. Soon after the tektites splashed down, huge tidal waves came roaring across the Gulf of Mexico from the impact site and crashed onto the shoreline behind me. It then knocked down trees and ripped logs, and the backwash of the wave carried those logs and deposit them on top of the tektites in this rock above me.
Thousands of miles away, little did the dinosaurs know death for them would be slow and even more agonizingly painful. In most of Central America, the impact of the meteor was devastating. Lush tropical forests teeming with life had disappeared beneath an ocean of water. Trees, once tall and mighty, were reduced to smoking stumps. For dinosaurs living on other continents, the disaster would now spark a chain reaction, igniting a series of lethal events. Proof of how globally fatal the impact really was has been recently discovered in the Gulf of Mexico. Research ships drilling thousands of feet deep off the Yucatan coast have recovered core samples dating back 65 million years. When the cores were analyzed, geologists found that they possessed a potentially fatal mixture of rock and gases.
The Chicxulub impact event hit two very important rock types. This is limestone and anhydrite. Locked within these rocks is a variety of toxic gases. For example, if I pour this liquid on one of these rocks, you can see the gases bubbling out from the rock. From the limestone, we would have produced carbon dioxide, which is a greenhouse warming gas. From the anhydrite, we would have produced sulfur dioxide.
Mixing these two with water vapor means big trouble. The impact would have thrown them into the atmosphere, creating a deadly cloud of doom.
Once in the atmosphere, the sulfur dioxide would have reacted with water to form sulfuric acid rain, which would have then rained out all over the world.
Ironically, if the meteor had hit anywhere else on Earth, the devastation would not have been nearly as severe, because the combination of minerals needed to create this deadly acid cloud is found on only 0.5% of the Earth's surface. dinosaurs perished simply because the impact occurred in the wrong place at the wrong time. This discovery solved the mystery of their extinction on a global scale. On impact, the meteor exploded, hurling a cloud of sulfuric acid into the air. Within hours, the jet stream carried it around the globe. The cloud blocked the sunlight for over 3 years, causing temperatures to drop to near freezing. As the gas cloud cooled, it fell to Earth as acid rain. For 10 years after the impact, Earth was showered by burning droplets of sulfuric acid. Starved of light, plants died and the food chain collapsed. A nuclear winter descended on a previously tropical world. Then carbon dioxide began to fill the air in vast quantities. Temperatures escalated to sweltering levels. Large creatures like the dinosaurs had less fresh air to breathe, little clean water to drink, and fewer things to eat. In the agony of death, the Earth fell silent. For 5,000 years, the Earth was virtually barren. Then slowly, nature recovered, beginning a new chapter in the history of life. Although the reign of the dinosaurs was over, their extinction is not unique. Many meteors have hit the Earth. Very big objects traveling very fast through space, like the recent comet Hale-Bopp, can get pulled into our orbit and crash, causing unbelievable destruction. In fact, scientists predict that every 65 to 100 million years, Earth is struck by a giant meteor. So if the extinction of the dinosaurs happened 65 million years ago, the question is not, could it happen again? But when exactly is our time up?